Recently, I've been working on some organic chemistry animations that are focused on the reactions that turn alkenes or hydrocarbons with double bonds into alcohols. With the first reaction we can look at is the reaction of the alkene in acidic conditions or acid catalyzed hydration. The alkene will react with a hydronium ion in solution to form a carbocation intermediate, which will then be attacked by a nucleophile. In this case, it's water. After removal of the excess proton, we are left with our alcohol product. In this case, the hydroxyl group is left on the more substituted double bond carbon, or the Markovnikov product. Since this specific reaction has a carbocation intermediate, it is open to carbocation rearrangements throughout the reaction. What if there was a case in which we needed to put a hydroxyl group on the least substituted carbon of a double bond? In that case, we can refer to hydroboration oxidation, which is a method of turning an alkene into an alcohol that puts the hydroxyl group on the least substituted carbon and avoids a carbocation intermediate. The specific regioselectivity for this reaction, or the reason it works the way it does, comes from the first step, or how borane interacts with the alkene. It's through this transition state where the hydrogen ends up on the more substituted carbon and borane ends up on the least substituted carbon, which is then removed later on throughout the reaction, resulting in the hydroxyl group ending on the least substituted carbon. Collecting more reactions that allow us to make distinct products throughout organic chemistry is very important.